All right, today we are doing graphing exponential functions, day 1, so 12.1a. All right, so in your section that says exponential form, I need you to copy down everything I wrote right here. Exponential form is used in population growth, radioactive decay. These are word problems, and for bank accounts, can also be a word problem. Bank accounts like interest that you earn on your money when you put it in a savings account. Yes? Parabolas and graphing is like, I'm going to throw a ball and I want to know how high it reaches before it falls to the ground. I can't think of things like that go down and back up again, like a submarine maybe in the ocean coming back up. You can track how something moves with a parabola. So those would be parabola word problems. Yeah.
What is the x by the b? Is it like b?
That's the exponent. The exponent is what we are plugging in for today.
Still recording.
I know, it's okay. All right, so the formula is y equals a. A is my y-intercept, b to the x. So there's going to be a number for a, there's going to be a number for b, which is my base, but there's not going to be a number for x. That is what we're going to use a table of values to plug in for. All right. Okay, so one more thing that I want to write as a vocab word is this. ASYMPTOTE. Asymptote.
What does that mean?
It is the imaginary line that the graph will never cross. I told you when I was explaining how these graphs looked that our shape of our line gets so close to the x-axis, but it never touches, ever, ever. So the imaginary line is this x-axis, is this horizontal line, because our graph will get super, super close, but never, ever, ever, not even infinity does it touch. So the asymptote is always going to be, sorry, real quick. Erase.
Bless you.
Y. Oh.
Whoa.
Learning curves. Hold on. Y equals 0.
You're just gonna like keep your learning curve there and not erase it?
If it bothers you, I can. I cannot. I don't know. It's not worth me wasting time about.
Oh, it's still recording.
All right, so let's go on to the next slide. Got all of our basics down. All right, so we're going to graph. And this is, right now this graph says this. Y equals 1 times 2 to the x. My 1 is my y-intercept. So down there at the bottom of the page where it says y-intercept, put 1, or like you could put this, 0, 1. My graph is going to cross the y-axis at 1. But I have to actually do this math and figure it all out before Yeah, a lot more color choices, a lot more tools. So this program is better. Okay, these are the numbers that you're going to plug in. -2, -1, 0, 1, 2. They're going to be plugged in the exponent spot. Y equals 2 to the -2nd. Okay, negative exponents. What happens when an exponent is negative? 1 over 2 to the 2nd, which is 1 over 4. So in the y, put 1/4. Want to graph as we go, or do you want to graph at the end?
Graph at the end.
Great, let's graph at the end.
Yes.
Next, we have 2 to the -1. Negative exponent, 1 over 2 to the 1.
It stays that way, so 1 over 2.
Mm-hmm. Two to the 0.
That's 1.
Anything to the 0 power.
And since we already did the work up
2 to the 1 power. No, this is not like that,
Oh, it doesn't work that way?
because this is not a parabola. It doesn't have an axis of symmetry that cuts it in half.
So no, we should do
Now we actually have to do the math. 2 to the 2nd power.
4.
Okay, 1/4 is our first. So I got 2 to the left and 1/4 up, which is like nothing. Barely anything. -1 to the right, 1/2 up. Zero comma 1. Told you my y-intercept was 1. Over 1 up 2. Over 2 up 4. So this shape will get dangerously close to the x-axis. You know the y equals 0 horizontal asymptote? But it will never ever touch, not even way past the graph at negative like 30. That's just one of the rules of graphing exponential functions. So draw your connect the dots. Why am I singing? So bad for my voice to sing.
Sing, Miss Grant, it'll make you better. You sound like a pistol.
So that's what my graph looks like. Now, we have to fill in all the bottom info.
Yes. Yes, we do.
Okay. Some things I'm going to focus on. I blanked out growth factor and I blanked out end behavior because we're not going to get so involved. This is very much an Algebra 2 concept. So the fact that we're doing it now means that
Or advanced. But will this be in the
we're
final?
super smart. Yeah, the basics will be on the final. Like we know what the y-intercept is. It was 1. Our horizontal asymptote will always be y equals 0.
Wait, why is it y and 0? Wouldn't it just be 1?
No, because remember how this imaginary line
Yeah.
that my purple line gets really close to but never touches?
Uh-huh.
All right, so now the domain means the x values. So this will go forever to the left and it'll hit all those negatives, negative infinity, forever left. Now to the right, it'll go up, 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 but it gets wider and wider and wider and wider.
And never touch that.
So my domain is going to also be for this, all real numbers.
Always?
Yes, always.
What's the right?
My range is going to be any number on the y, because y is range, right? So any number bigger than 0. Because see how it's above 0, like all up here?
Yeah.
Greater than or equal to 0. That's
What-
my range.
What's the horizontal asymptote?
The horizontal asymptote means that this line, this purple line, will never go below the black x-axis. The asymptote is like the boundary point. It's like the fence. You cannot go below that.
Oh.
Yes?
The range will always be y is greater than.
No, the range will be depending on, well, Yeah, the range will always be y is greater than 0 because it never goes below the x-axis. It never goes into the negatives.
So it's gonna be like 100% or like 95%.
100% of the time.
Alright, yeah. Not like 95.
Okay, now we have this one, number 2. Okay, remember, it's y equals a times b to the x. A is my y-intercept. There is no number in front of 1/2. It's like 1 times 1/2, whatever. So my y-intercept is still going to be 1, or 0, 1. To write it properly. My horizontal asymptote will always be y equals 0.
All real numbers as well.
My domain will be all real numbers, but we have to graph it first before we can verify the range. Okay, let's plug in these numbers that we did last problem. 1/2 to the x power. Okay. -2, -1, 0, 1, 2. 1/2 to the -2nd power. We need to do it on the side of the paper, side of the board. 1/2 to the -2nd power. Okay.
Wait, that's really two.
Now, first of all, the easiest way to do this is to raise the 1 to the -2nd power and the 2 to the -2nd power. 1 to the -2nd over 2 to the -2nd. So do that first. And then, since they're negative exponents, they're going to change positions. The bottom one will go to the top one will go to the bottom. You know how negative exponents switch positions? So now, this one goes up top, this one goes down bottom, and my signs are now positive. So, it's 4. Okay, you're really lost because 1/2 to the -2nd power,
Yeah, where'd you get that negative? Wouldn't it be two?
you can, if you want to, you could just flip it. Let me see if I can erase some of this stuff, if this will work. Oh, look, good. Okay. Something that might be easier for you to do is this. Flip it 2 over 1, and then make it a positive 2. Do you like this way better than like raising 1 to the -2nd, raising 2 to the -2nd, and then flipping?
Yeah.
So when you have a fraction to the negative exponent, let's do this then. Let's flip the fraction, and the exponent will become positive. What's 2 over 1 to the 2nd power? 4. I need space.
Erase.
Okay. All right. Let's do now 1/2 to the -1 power. So we just decided when there's a fraction negative exponent, we're going to flip it. So it's going to be 2 over 1 to the positive power. What's 2 to the first power? 2. All right. What's 1/2 to the 0 power?
1/2.
Anything to the 0 power.
1.
What's 1/2 to the first power? 1/2. Now we're just plugging in, right? 1/2 to the 2nd power. 1 squared over 2 squared. 1/4. Okay, graph these ordered pairs. Negative 2 comma 4. 2 to the left, up 4. Negative 1 comma positive 2. There's my y-intercept 0, 1. 1 comma 1/2. 2 comma 1/4. Okay, you're going to get dangerously close to the horizontal asymptote, but you're never going to touch that imaginary line. It's like a fence. Don't touch, don't touch, don't touch.
Oh my goodness.
Fail. All right.
Wow, how is that a fail, Miss Grant? That's a pass for me.
So, range. Where is my graph hitting on my y's? See how it's all up here? So it's going to be the same thing. As long as your graph is above the x-axis, you're going to get y is greater than 0. No, it's poorly written. Yeah, if you want to fill out all these words at the bottom before you do it, great. Okay. Hey, notice how number 1 looks different than number 2? Anyone?
Yeah.
They're going different directions. Okay? I'm going to have you write down something after we finish this one. Number 3. Here's what it means. Negative 3 to the x power. Y equals a times b. That negative is going to go with the 1. The reason that I don't write a 1 is because we're just doing basics. But as we go, like tomorrow, we're going to have more numbers, like an a and a b. So your equation is really negative 1 times 3 to the x. Write that down. My y-intercept is negative 1. Okay, hey, this is a negative, like it starts out negative. When we had parabolas, negative meant that it went downward facing. What do you think this is going to mean when it has a negative in front?
It's going to go up. It's going to go down.
Trevor was right. It's going to be under. It's going to be below, which is going to change my range. Okay, same numbers. Negative 2, negative 1, 0, 1, 2. Negative 1 times 3 to the negative second power. Negative 1 times 3 to the negative first. Okay, the 3 goes to the negative second power. So, what's 3 to the negative second? What fraction does that become? 3 to the negative second power. What fraction does that become? 1/9. 1 over 3 to the second. 1 over 9. Because it's a negative exponent. Negative exponents become fractions. I'll show you. Negative 1/9 is my y. Negative 1 times 3 to the negative 1. What's 3 to the negative first? 1/3. Negative 1 times 1/3, negative 1/3. Negative 1 times 3 to the 0. Am I going too fast, too slow, what?
A little bit too fast. It's alright.
Okay. Negative 1 times 1.
Negative
Now let's do our 1 and our 2. Negative 1 times 3 to the first. Negative 1 times 3 to the second. So this table of values is no more difficult than what we were doing with parabolas. Okay. Negative 1 times 3. Negative 3. Negative 1 times 9. Negative 9. Okay. So here we go. Graph them. 1/9, negative 1/9. Negative 2, negative 1/9 is like, one thing I can't do is like expand this graph and make it bigger to see. Sorry about that. Let's just zoom in. What? You learn new things every day, people. Every day. Okay, here we go. 2 comma negative 1/9. Oh, negative 2. 2 to the left, down 1/9. It's like nothing. Negative 1, negative 1/3. Negative 1/3 is like a little bit lower than 1/9, but barely. How about this? You guys tell me what the ordered pairs are, and I'll just draw this like zoomed in graph for you. What's my next ordered pair? Y-intercept. 1, negative 3. Oh, negative 9. And the dots stay where I put them. Ingenious. 2, negative 9. I didn't do it enough. Another cool thing, watch this.
Oh, what the?
That wasn't that impressive. I was trying to do something else. Oh, 2, negative 9. Okay. Because there's a negative in the very front, it's below my x-axis. So connect your dots, la, 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 la. Oh. Don't touch that x-axis. Anyways. Now I can do my, wow, this program is so much better. Horizontal asymptote is still y equals 0. It's your x-axis, y equals 0. Up or down 0 on the y-axis. Domain. Okay, all numbers to the left, negative infinity, and the further down this graph goes, the wider and wider and wider. So I'm going to put all real numbers. And then my range is not y is greater than 0.
Y is less than 0.
Look who's smart.
Me.
All right, let's see if I did another one. Okay, you need to write this down somewhere because you need to know how to know which way it goes. So find a spot somewhere. Write this down.